So I am recording, but feel free to raise your hand or to just yell out and I will stop. I could always go back and re-record. So we are doing 8.6, final section of chapter 8 here, solving rational equations and inequalities. Okay, so this is technically going to be video number 1. And on this one, we're going to focus in on just solving rational equations. Okay, it's just basic algebra. It's heavy algebra. But the really fun part of this lesson is when we start doing inequalities. Okay, so let's start with equations today. And then tomorrow we'll move on to inequalities. So let's begin with equations. How do we solve equations? Whenever you have a fraction inside an equation, you can get rid of one fraction at a time by multiplying everything by the denominator of that fraction that you want to get rid of. Or you could get rid of all fractions at the same time by multiplying everything by the LCD. Now that might be complicated for some of us. For me, I actually prefer to get rid of one fraction at a time instead of multiplying everything by the LCD. Let's jump right into this worksheet. Of course, I'm not going to explain all of them. I'm only going to explain these highlighted ones right here. So I'm going to start with number 1. We have a proportion. Technically, you could cross multiply, but sticking with the general concept of getting rid of fractions by multiplying everything by the denominator, we're going to stick with that. So that first fraction, I'm going to multiply by x minus 1 so it could cancel out, so I won't have a fraction anymore. But again, you do it to the whole entire equation. So there's another side, you're going to multiply that by x minus 1 as well. Okay. So when you multiply the first fraction by the denominator, it cancels out. There's no more fraction. You have a nice, beautiful x. You have the equal sign. And over here, the x minus 1 will not cancel with the 2. So you do have to distribute 1 times x and 1 times negative 1. Obviously, it doesn't change anything, but it's still a fraction over 2. Up on top, you have that x minus 1. So now you have this simple equation that has x equaling this fraction. We got rid of the first fraction on the left side. Now let's get rid of the fraction on the right side by multiplying both sides by that denominator 2. And you end up with a 2x equaling x minus 1. And that's just a regular equation with no more fraction. All you got to do is move the x's to one side, solve for x. So I'm going to subtract x. 2x take away 1x is a single x equaling negative 1. And ladies and gentlemen, that might be your answer. Why do I say might be? Because you got to take a brief moment and make sure that when you plug in that x value of negative 1, you don't end up with 0 in the denominator. Because if you end up with 0 in the denominator, that makes it undefined, which means that it's no longer an actual answer. It's just an extraneous solution. Okay, so always take a moment and just make sure that you don't have 0 in the denominator. What do I mean by that? Like, let's say I would have done all this work and the answer is x equals positive 1. And you plug in a positive 1, 1 take away 1 is 0. You can't divide by 0, that makes it undefined. So that's when you would say, oh, the answer is not x equals 1, it's no solution, right, in that case. Let's move on to a different question. Let's jump to number 5, right? No, let's go to number 4. I almost forgot that one. This is a good one. Nice and simple, basic algebra here. You want to get rid of the fraction. How do I get rid of that fraction? I multiply everything by the denominator, which in this case is z. So let's put a z everywhere. I'm going to put a times z right there, a times z right there next to that other z, a times z right here next to the 3. Okay, so we end up with 3z minus, what's z times z? Z squared equals, and the fraction disappears, cancels out, you get a nice, beautiful 2. Okay. Now, right here, you should notice that this is a quadratic. And we've been dealing with quadratics a lot, right? So the idea is move everything to one side. That way you'll have a quadratic trinomial that maybe you could factor and apply the zero product property where you split it and solve. That's what we're going to do here. We're going to move the 2 to the other side over here. And you can't really subtract 2 from the z squared or from the 3z. So we're just going to rewrite everything. And it's better to write it in order. I'm going to write the z squared first. So that's going to be a negative z squared first, and then the positive 3z plus 3z, and then the minus 2, and then the equal sign, and then 0. Now, hopefully I could factor it. And hopefully you remember that when you have like an x squared, you want it to be a positive x squared, not a negative x squared. In this case, same thing, it's a z squared. You want it to be a positive z squared, not a negative z squared. So what are we going to do to make that a positive? We're going to factor out a negative 1. Okay, we're going to factor out a negative 1. That way on the inside, you have positive z squared, a minus 3z, and a positive 2. And it's still equal to 0. Are you guys following me? So at this point, if you really wanted to, since it's an equation, right? Since it's an equation, you could do whatever you want to an equation as long as what you do to one side, do to the other. So if you wanted to, you could get rid of this multiplication of negative 1 by dividing by negative 1 and dividing by negative 1. And then you'll end up with the quadratic trinomial z squared minus 3z plus 2 equals 0, because 0 divided by negative 1 is still 0. Now this is a quadratic trinomial, and let's attempt to factor it. How's that? By doing parenthesis, 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 z, z, and then thinking what times what is the c value, the positive 2, that if you combine together is the b value, negative 3. I always say make a list of the multiples of c. In this case, the list of the multiples of 2. How could you get 2? It's just 1 times 2, and that's it. Now, if you add the 1 plus 2, will you get a negative 3? You get a positive 3, not a negative 3. So you have the right number, just the wrong sign, which means you have the right numbers, just the wrong signs. So change that to a negative 1, change that to a negative 2, and that's what you plug in right here, a minus 1 and a minus 2. And that's the factored form of it. You got z minus 1 times z minus 2 equals 0. Now, why would I do that? Because now that it's in factored form, something times something equals 0. You could say that that first something could be 0, so that z minus 1, you could set that equal to 0, and the z minus 2, you could set that equal to 0. We did this last semester, right? Where you factor, you split it, and you solve it using the zero product property. So now we could solve both, and we'll have our two answers. Should I show my work? Sure, why not? Plus 1, you end up with z equals 1, and then plus 2, you end up with z equaling 2. And then you got to take one brief moment and make sure that when you plug in the 1, you don't get 0 in the denominator. You plug in the 2, you don't get 0 in the denominator. So those are your two answers right there for this question, this equation. Let's move on to number 5. Again, it's a proportion. You could cross multiply, or you could just get rid of one fraction at a time. Which one do you want to get rid of first, the left one or the right one? You pick. Left? Okay. I'm going to get rid of that d plus 1 on the bottom by multiplying by d plus 1 up here on top. And I'm not even really multiplying, it just cancels out, right? But what you do to one side, you do to the other side. So you're going to multiply over here by d plus 1, okay? So yes, right here, it cancels, and I end up with a nice, beautiful 2 equaling. Now, over here, the d plus 1 does not cancel with the d minus 2. So you're still going to have a fraction with the d minus 2 on the bottom. And up on top, you're supposed to distribute 1 times d and 1 times 1, which doesn't change anything. It's still going to be a d plus 1, right? 1 times d is d, 1 times 1 is 1, so it's still a d plus 1 in the numerator. So now let's get rid of the other fraction by multiplying both sides by the denominator d minus 2. So you're going to go times d minus 2 here times d minus 2 over here. So yes, they cancel. You end up with a nice, beautiful d plus 1, no more fraction. And on the left side, 2 times d, that's 2d. 2 times negative 2, that's negative 4. And there's your new simplified equation with no more fractions. And of course, we have d's on both sides of the equal sign. You don't want d's on both sides. So let's get rid of one of the d's. I'm going to get rid of this guy by subtracting d. 2d, take away 1d is a single d. Bring down the minus 4, the equal sign, the 1. You want to get rid of the minus 4, do the opposite, plus 4. You end up with d equals 5. And you got to double check and make sure that it doesn't cause the denominators to become 0. Plug in that 5 plus 1 is 6. Plug in the 5 right there, 5 minus 2 is 3. And it doesn't. So that is an acceptable answer. Now, if you wanted to really be 100% sure that you have the right answer, you could actually plug in the 5 where the d's are at, and make sure that the whole thing's a true statement. Like plug in a 5 right there, 5 plus 1 is 6. 2 over 6 reduces down to 1/3. Plug in a 5 right there. 5 take away 2 is 1/3. So yeah, 1/3 equals 1/3. It's a true statement. You're 100% positive that that's a correct answer. And you could even plug this in with the calculator so you could double check and make sure you have the right answer. Let's move on to something more fun, like number 10. Oh, this one's ridiculously fun. You probably are not going to have enough space on your worksheet unless you write super tiny, okay? We have two fractions, but technically this equation has 1, 2, 3 terms in it, right? You got one fraction, we have a number and another fraction. So we're going to get rid of the fractions, but whichever one, like which one do you want to get rid of, the left one or the right one? Left. We're going to get rid of both. Let's start with the left just because you said so. So we're going to put times b plus 1, but you also have to multiply the b plus 1 times this 4 and then by this fraction. So you got to put the b plus 1 on the 4 also and on this fraction. Okay? This one's going to get fun. Now, yes, this first fraction right here, it's no longer a fraction because the b plus 1 on the bottom cancels with the b plus 1 on top. So there's no real multiplication. You just cancel it out. You get a nice, beautiful 3b minus 2 equals. Now, over here is where it gets fun. 4 times b is 4b. Let me show my work in blue. 4 times b, 4b. 4 times 1, positive 4. Okay? Now, over here on this fraction, the b plus 1 will not cancel with the b minus 1. So what does that mean? That I need to actually multiply the top with the top since it doesn't cancel. I actually need to multiply it. And what we need to recognize is that the numerator is a binomial. So we really have the binomial b plus 2 times b plus 1, and they're both in parentheses. So that itself is going to be a rather lengthy distributed property problem. Let's do that. Check this out. B times b, I'm just going to write it up here, b squared. b times 1 is 1b. And then this positive 2 times b is a positive 2b, and the positive 2 times 1 is a positive 2. And of course, we could combine the 1b plus the 2b to give us a total of 3b. So we really got b squared plus 3b plus 2. And that's what we're going to write on the numerator of this fraction, okay? So let's understand this. This minus sign is still there, and the fraction's still there, but we put this quadratic trinomial as the numerator. So here we go. We have the minus sign still there. We have the fraction still there. But we're going to put b squared plus 3b plus 2 on the numerator. B squared plus 3b plus 2 on the numerator. And on the denominator, it's still b minus 1. So now what? Yeah, we're going to get rid of the other fraction, the b minus 1. We got to multiply everything by b minus 1. But you got to think about it. If I were to multiply by b minus 1, yeah, that's easy. It cancels out. But I'd have to multiply this 4 by b minus 1, the 4b by b minus 1, the negative 2 by b minus 1, and even the 3b by b minus 1. Dang, I even got tired just saying that. So it's a lot of work. So why not make this ginormously ugly equation a little bit smaller, a little bit nicer? So how am I going to do that? Let's move things around. Like, for example, we could move the number to the right and the letter to the left, or maybe the letter to the right and the number to the left, make it a little smaller, or move everything to one side. I'm going to choose to, let's say, move the 3b to the left side. I mean, to the right side. I'm sorry. It's on the left side. I'm going to move it to the right side. I'm going to subtract 3b. That'll cancel out. And when you do to one side, do to the other, subtract 3b. So by us subtracting the 3b, it makes it a little smaller and nicer, and we might as well do 2 steps in one. We're going to get rid of the 4. By subtracting 4, that'll cancel out. Subtracting 4. So we're going to end up with a new equation that reads negative 6 equals 1b, or you could just put a single b like that. And then this minus sign and this fraction, it's still there. You're just going to bring it down. Okay, so I just brought this down. Now we need to get rid of the other fraction, multiply everything by b minus 1. So you got b minus 1 here, that cancels. You're going to have to multiply by b minus 1 right here. You're going to have to multiply by b minus 1 over here. It's probably one of the longest questions on the worksheet. We're going to distribute negative 6 times b. That's negative 6b. Negative 6 times negative 1 is positive 6. You have the equal sign. B times b is b squared. B times minus 1 is a minus b. Now, here's where it gets interesting. This minus sign belonged to the whole fraction, which means that it belongs to this whole quadratic trinomial that's left over after canceling out that fraction. So it's very important that we put that minus sign in front of parentheses with the b squared plus 3b plus 2 inside the parentheses, because if you don't do this, you're going to mistakenly think that it's just a minus b squared and that the other ones are positive, and that's incorrect. You got to distribute the minus sign into each term. So that's what we're going to do right here. We're going to distribute that minus sign. The minus in front of the b squared is a minus b squared. The minus in front of the 3b, that's a minus 3b. The minus in front of the 2 is a minus 2. Then you bring down the b squared and the minus b. And then on the right side of this equal sign, you could combine like terms and make it nicer. The b squared minus b squared, they eliminate. And if you got a negative b and a minus 3b, that'll become, on the right side, a negative 4b. And it's still with the minus 2. And on the left side, you have a negative 6b plus 6. And then from there, you move the b's to one side and the numbers to the other, and you'll have it solved. So we're going to go plus 4b, plus 4b. You end up with a negative 2b plus 6 equaling negative 2. A couple more steps and then we're done. We're going to subtract 6. You end up with a negative 2b equaling negative 8. So your final answer, dividing by negative 2, dividing by negative 2, you get b equals positive 4. And then from there, you just double check, make sure that your denominator doesn't end up being 0, and you're good. Of course, if you wanted to check the whole thing, you could get a calculator, plug in the 4 right there, and up there, and down there, and verify that the left side does equal the right side. So that was the hardest one on today's lesson. The other ones are easier. Let's take a look at number 14. We have 3 fractions. We need to get rid of all 3 fractions. I recommend always factoring whatever you possibly can. So obviously you can't factor anything out of here. There's no GCF. But right here, this is a quadratic binomial. And you could think parenthesis, W. What times what is negative 4, that if you combine together is the middle term, which there is no middle term. There is no middle term. So what times what is negative 4, that if you combine together is nothing. If you want, you can make a list like negative 1 times 4 or negative 2 times 2. It's obvious that it's a negative 2 and a positive 2. So I have factored this guy. Now, why would I do that? Because when you cancel out fractions, right here, it happens to make it way easier. Because let's say I want to cancel this fraction out first. I'm going to multiply everything by w plus 2. W plus 2, that disappears with that. No more fraction. Nice, beautiful 1. Put a plus sign. But when you multiply over here, w plus 2, it does not cancel with this guy. It doesn't, because they're not the same binomial. So you actually are still going to have a fraction. There's your fraction. And you have to distribute. 1 times w is 1w, or just w. 1 times 2 is 2. So you have a w plus 2, and it's still over w minus 2. The equal sign comes down. Now, when you multiply on the right side by the w plus 2, because it's in factored form, the w plus 2 and the w plus 2 could cancel out. So that's why we factor anything possible before anything else, because it makes it a lot easier. Now, we still have a fraction, but at least it's not a binomial times a binomial in the denominator anymore. It's simply 4 over w minus 2. And now we have the fraction that has a denominator w minus 2. Let's multiply everything by that denominator w minus 2, w minus 2. w minus 2. So obviously 1 times w minus 2 is still going to be w minus 2. And obviously the w minus 2 cancels with the w minus 2. No more fraction. It's a plus w plus 2. Bring down the equal sign. Over here, that also cancels. It's a nice, beautiful 4 on the right side. Let's now simplify and solve this thing. We're going to combine the w's. So w and w, that's a total of 2 w's. And then the minus 2 and the plus 2, those eliminate. So there's no more numbers. It's just 2w equals 4. And that's a one-step equation. All you got to do is divide by 2, and you'll get your answer, w equals 2. But you got to double check it. And if you take this answer 2 and put it right here, 2 take away 2 is 0. Anything divided by 0 is undefined. So this value actually makes it undefined. So this is not an answer. It's extraneous. I mean, you shouldn't write but. It's not an answer. So what is our answer? No solution. So you could use this symbol, the 0 with the line through it. You could write out no sol, right? Or write out no solution, or NS, whatever you want. But that's your answer, number 14. Because when you plugged it in, it made it undefined. There will be several questions on this worksheet that you have to be able to see this and factor it the way we did here, okay? Let's flip it over to the backside. On this backside, I'm going to do number 16. But look, 17 is similar to the one we just did. You're going to have to factor that guy. Same thing here, you got to factor that guy. But let's do 16 here. So let's factor anything possible. I'm going to factor the quadratic, or I'm going to try to factor the quadratic trinomial, putting a p there and a p there, thinking what times what is negative 12, positive 12, that if I add together is 7. You might want to make a list. How could you get 12? 1 times 12, 2 times 6, 3 times 4. Obviously, the pair of numbers you want is 3 and 4. You don't have to change any signs, 3 and 4. So all I've done is changed the quadratic trinomial into a binomial times a binomial by factoring. Why did I do that? Because that makes our lives a lot easier. When you want to get rid of a fraction, like let's say you want to get rid of this fraction, you're going to multiply everything by that binomial p plus 4. So you're going to put a p plus 4 right there. You're going to put a p plus 4 right there. And you're going to put a p plus 4 right there. So of course the p plus 4, because it's in factored form, cancels with the p plus 4. And then over here, the p plus 4 does not cancel with the p plus 3. Actually, I should write this out. Let me write this out. It's still a fraction, but at least it's a lot nicer. You have the 12p plus 19, but it's now only over p plus 3. That's all that's left. And then you have the minus sign, and you have this other fraction, and you have to distribute the 3 times p, that's 3p. 3 times 4, that's 12. And it's still over p plus 3. And then you have the equal sign. And of course, p plus 4 does cancel with the bottom p plus 4. That's nice. You get a nice, beautiful 5. So it's important to factor first so it could cancel. And now it's really easy because all you could do is multiply everything by p plus 3 and you're good to go. So let's multiply by p plus 3, multiply by p plus 3, multiply by p plus 3. So right here, p plus 3's cancel. Right here, p plus 3's cancel. And over here, it doesn't cancel. You have to distribute. So you have your equal sign. 5 times p is 5p. 5 times 3 is 15. Over here, there's no more fraction. So I just write down the 12p plus 19. 12p plus 19. Same thing over here. This canceled, so I have no more fraction. However, once again, whenever you have a minus sign, you have to put this in parentheses because the minus sign belongs to the whole fraction, which means that it belongs to the whole numerator that's left over. So if you don't put it in parentheses, you're going to make the mistake of writing it like this, negative 3p plus 12, and then you keep going, and that would be wrong because you need the parentheses around what was up here. That way you don't forget to distribute that minus sign. So distributing the minus sign, that's a negative 3p. That's a negative 12. Bring down the positive 12p, the plus 19. Bring down the equal sign, the 5p plus 15. Now we have an Algebra 1 question. It's just a bunch of p's and numbers. So I want to combine the like terms on the left side. 12p, take away 3p. That ends up giving you a 9p on the left side. And then you could combine the 19 minus 12, and that'll give you a 7, positive 7 on the left side. You have the equal sign, and you bring down the 5p plus 15. All you got to do now is get the p's to one side and the numbers to the other. I'm going to subtract 5p, subtract 5p. We end up with 4p plus 7 equals 15. Final step, subtract 7, not the final step. One of the final steps. We now have, oh, I'm running out of space here. You probably ran out of space too. 4p equaling 8, divide by 4, p equals 2. Just make sure that it won't cause the denominator to become 0. If you plug in a 2 right there and a 2 right there, there's no way that's going to become 0. Plug in a 2 right there, that's 5, that's not 0. Plug in a 2 right there, it's not 0. So this is your answer, p equals 2. So I believe with the questions that I just explained, you should be able to do the other ones all the way to 18 as practice. And the solutions are posted on Google Classroom so you can check your answers. Now, tomorrow, we're going to stop this video here, but tomorrow we're going to continue on with inequalities. And inequalities are way more challenging because you have these steps to follow on inequalities. Step 1 is to solve it as if it were an equation or as an inequality. And then step 2, set the denominators equal to 0 and solve it so you get different answers. And then step 3, plot all your answers on a number line, and then you got to test the areas. So I'm not going to scare you guys with this right now. We're going to hold off till another day. Right now, let's just practice that rigorous algebra by getting rid of fractions by multiplying everything by the denominator of the fraction you want to get rid of. So please work on the worksheet. Check your answers on Google Classroom. We'll continue this with tomorrow on tomorrow's next video.